Chapter 6, Lesson 4 of Advanced Algebra, continuing our look at solving polynomial equations. And in this video, we want to look at solving polynomial equations by factoring. Now, when we were working with quadratics, you remember, while many quadratics factor, factoring doesn't work all the time. However, if quadratics were able to be factored, it was a quick way to solve it because, again, we're looking to get these equations in factored form equal to 0, because once we have the factors, we can just use we can apply the zero product property and determine what makes each one of those factors 0, thus giving us the solution to the equation. The problem with when we work with these higher degree polynomials, cubics, quartics, quintics, etc., factoring is a lot more difficult than it is with quadratics, so we usually go to graphing. What we want to do in this video is look at two special types of cubics that if the polynomial is a cubic of this particular form, then we can factor those and thus use factoring to solve the equation instead of graphing. So it requires that we notice something about the polynomial and the form that it's in, much like we did when we were doing the difference of two squares. You remember that when we were doing quadratics, that if the first term was a perfect square and the last term was a perfect square and it was a minus sign, that all we had to do was it would always factor into the same form, meaning one of these factors would have a plus sign in the middle, one of the factors would have a minus sign in the middle, and the first term of both would be the square root of this term, and the second term of both would be the square root of this term. So if we recognized the difference of two squares, we could quickly factor it because it always factored in the same way. And you remember there was a series of questions that we had to go through in order to do that. We had to look at, is the first term a perfect square? If it was yes, then we would use x squared. Is the last term a perfect square? Yes, and then we would put that in there, and then we'd always have one would be plus and one would be minus, and so that would give us factored form in a very quick way. Okay, so if we recognize the difference of two squares, and that's really what it comes down to, is recognizing what it is and then remembering what form it will always take. Well, we can apply the same thing if we're looking at the sum or difference of perfect cubes. Okay, so if we have a polynomial that is a perfect cube plus another perfect cube, or if we have a perfect cube minus another perfect cube, it will always factor into these forms. And you'll notice that a here is just the cube root of this term, whatever it is. The b would be the cube root of this term. Okay, and then that's the first part, and then the second part is you have the a term, which this is the cube root of this now squared. The last is the cube root of this now squared. And the middle term is always the a times the b. Now I want you to notice the signs, because we're going to use an acronym called SOAP. Okay, so when you have the sum or difference of two cubes, you always want to use SOAP. And what this stands for is same, and then opposite, and then these two go together, always positive. Okay, and what that has to do with is the signs. You'll notice that if you're looking at a sum of two cubes, that the first sign is the same, the second sign is the opposite, and the third sign is always going to be positive. So same, opposite, always positive. When you're looking for a difference, it's the same acronym. The first sign is the same, the second sign is the opposite of this one, and then the last one is positive. So whenever you're factoring the sum or difference of two cubes, as far as the signs go, it's the same. First sign is always the same, second sign is always the opposite of this one, and then the last one is always positive. So you'll always want to use SOAP. So let's look at a couple of examples so you'll kind of see how this goes. And really what it comes down to is just remembering these values here. This is the a, this is the b, this is the a term squared, this is the b term squared, and then this is the a times the b. Alright, so you just have to memorize those, and you remember to use SOAP. So let's do a couple of examples. Well, that was already shown to you. So we ask ourselves, is the first term a perfect cube? And yes, it is, and the cube root of that is a, right? And we ask ourselves, is the second term a perfect cube? And we say, yes, it is, and then the cube root of that is b. So now we know that they are a sum of perfect cubes, so the signs are going to be the same, the opposite, and this one's always positive, and then I know that the a goes here, the a squared goes here, okay, so I know that that goes there. I know the b goes here, and the b squared goes here. And then the middle term is the a times the b, so this would be my factored form. Now before we go further, there's one thing that's very important to note. While we do have this factored, it's not completely factored, because you'll notice, what do I have here? I now have a quadratic in here, and so I'm going to have to factor this one now using the quadratic factoring tools that I know, if it factors, and if it doesn't, then I'll have to solve this quadratic part of the equation using the quadratic formula. You remember when we were working with quadratics, there was 5 different ways that we used in order to find out what made that equal to 0. Factoring was nice if it worked. If it didn't, we had to complete the square. If there was no middle term, we could use extracting the square root, or we could always fall back to the quadratic formula. So in most cases, you're going to do one of the two. You're either going to be able to factor this, which you want to do, or you'll want to use the quadratic to find out what makes this 0, because again, if this is equal to 0, we're trying to find out what makes this 0. Okay, so just note that when you factor this perfect cube, when you factor it once, you're not done, because now you have to factor this again with the goal of finding the factors, because once we know the factors, then we just need to figure out what makes each one of those factors 0, and we have our solution. Okay, so let's do a couple more factoring examples using this method, and then we'll, in the next video, maybe we'll do a few where we actually solve the equation by factoring. Okay, so in this example, again, we have to ask ourselves, is this a perfect cube? And yes, we can take the cube root, and that would be x. Is the second term a perfect cube? Yes, 4 times 4 times 4. And you'll get to know these the more you use them. So because this is a plus sign, remember SOAP, this one's the same, this one's the opposite, this one's always positive. So the x goes here, and the x squared goes here. So this is the a term, and this is the a term squared. Then the 4 goes here, and then 4 squared goes here. That's the b term squared. And then the middle term is the a times the b, or 4x. So now I have the factored form. Now I would have to go ahead and factor this quadratic in order to finish solving it if I was going to solve it. Okay, so this is the same sign, this is the opposite, and this one's always positive. All right, let's do another example. All right, so we have to ask ourselves, is this first term a perfect cube? And yes, it is. The cube root of 125 is 5, and the cube root of x cubed is x, so that is a perfect cube. Is this last term a perfect cube? And yes, the last term is a perfect cube because 3 times 3 times 3 is 27. So this is a minus sign, so I'm going to use SOAP. So this one's the same, this one's the opposite, and this one's always positive. So now all I have to do is put the values in the same place. So a goes here, and a squared goes here. So I'm going to have to square that. That's going to give me 25x squared. B, the 3 goes here, and b squared goes here. And then the middle term is a times b, so 5x times 3 would be 15x. So this would be the factored form. Then again, if I wanted to go further and I was actually solving it, I would then use the quadratic formula or factor this quadratic to actually finish solving this equation for x. All right? Okay, so hopefully that's good for you. In the next video, I'll do a number of examples for you solving these equations using factoring as a method for solving.